So today we will discuss about moment of inertia and product of inertia. Moment of inertia or product of inertia of a body. So let us define with definition. Let us start with definition. So some definitions are here. And moment of inertia. First is moment of inertia. Moment of inertia of a particle. Moment of inertia of a particle of a body. Particle along with a straight line or line. Moment of inertia of a particle of a body or a particle along with a line. Yeah, with a line means suppose this is a particle, means this is a body, and here this is a particle P with mass m. Here the mass of particle P is m, and suppose this is the line. AB is a line. AB is a line, and the perpendicular distance from P to AB is R. Perpendicular distance from P to AB is R. So here is suppose means let P is a particle of mass m. P is a particle of mass m. This is a P particle of mass m, and AB is a line, and AB is a line. So perpendicular distance from P to AB is R. So, and perpendicular distance from P to AB is R. P is a particle of mass m, AB is a straight line, and R is perpendicular distance from P to R. Then moment of inertia is mi. Moment of inertia of P is equal to mr square. Mr means mass of particle. What is the mass of particle? Mass of particle and square of perpendicular distance means perpendicular distance square of perpendicular distance of a line from a line means mass of product m and perpendicular distance square of perpendicular distance with the particle from this line AB. So this is the moment of inertia mi. In short we say mi. Mi means moment of inertia of particle P with respect to AB. And suppose if we have to find particle distance of a whole body for moment of inertia of whole body and moment of mi of a body, moment of inertia of a body whose mass is capital M. So moment of inertia of a whole body is here, for moment of inertia of one particle is mr square, and whole body is means we will add mass of all particles. We will add mass of all particles. So it becomes summation. Hmm? Summation m r square, or we can write r square summation m. Summation m is particle of a mass. A particle means mass of a particle. And what is summation m? Summation m is mass of a whole body. So what is mass of whole body is capital M. So this is m r square. So moment of inertia of a body is equal to capital M r square. Now similarly we will find moment of inertia of a system of particles, system of particles of a body. Means there are, suppose m particles or n particles, so we have to find the moment of inertia of n particles. So here, suppose this is particle m1, here we will decide this is m1 particle, suppose p1 of mass m1, m2, here m3, so like this one, mn, and perpendicular distance is r1, r2, r3, and suppose this is r. So we can, the same method, the mass of particles m1 r, m1 to mn. So mass of particles are m1 to mn, and the perpendicular distance and perpendicular distance is from AB, perpendicular distances from AB are R1, R2 to Rn respectively. So these are the particles of mass m1, m2, mn, and the perpendicular distance from AB is and R1, R2, Rn like this. So moment of inertia of system of particles is equal to, means moment of inertia of P1 is m1 r1 square plus m2 r2 square 2 plus mn rn square, or we can write in summation I is equal to 1 to n mi ri square. Suppose 3 particles are given, so I is equal to 1 to 3, n are given 4, 5, 6. What is given, we will make here summation m I 1 to n mi ri r square ri square. This is r2 square. Now we come to radius of gyration. What is radiation of gyration? Radius of gyration. Suppose m is, or let m is mass of a body, m is mass of body, and I is moment of inertia of a body. Then we define, then we take real values k, like we take real value k, means here what is value k? K square is equal to n I upon n. I upon n. I upon n. What is I? Means summation. Moment of ni square and summation. Or we can write integral r square dm over integral dm. So this is a radius of gyration along about a straight line. So this is radius of gyration about a straight line AB. Gyration is of a body. So radius of gyration of body about this straight line is known as integral r square dm over integral dm. So this is radius of gyration. Now come product of inertia of two perpendicular axes. Product of inertia about two perpendiculars axes. Two perpendicular axes. Suppose these are perpendicular axes OX and OY. This is X, Y X dash, Y dash, O is this. And P is a particle. P is a particle. Coordinate of P is X and Y. So perpendicular distance, this is Y and this is X. So let OX and OY are perpendicular axes and P XY is a particle. XY is a particle. So perpendicular distance from OX and OY are Y and X respectively. From OX, the perpendicular distance from OX is Y and this is X. Here, this is X. So product of inertia, product Pi, we write product of inertia Pi of this particle P xy, what is some n xy, m xy. Particle of body is m xy, summation m xy means mass of particle and perpendicular distance from axis, means mass of particle and perpendicular distances from OX and OY. If summation, if we use summation, it means whole body. Product of inertia of a body about these perpendicular axes OX and OY. If we do not use summation, then product of inertia of a particle. Here, this is summation m is whole body, and this is here you can use summation. This is product of inertia. Now, if it is given in 3 dimensions, product and moment of inertia, moment of inertia and product of inertia in 3 dimension. In 3 dimension, coordinate with about with 3 dimension, about with straight line, about with 3 mutual, or with respect to